Problem number 42. This is going to be a bit of a combo Green's theorem and Jacobian change of variable substitution kind of problem here. So suppose R is the region xy plane, the first quadrant, determined by these inequalities right here. So these are going to look like these bounds x and y, x times y is between 3 and 8 because it's going to be between these curves. Y over x is between 3 and 8 because it's going to be between these lines here. So this is our value, this is our region R here that we are integrating over. C is the boundary of R oriented counterclockwise as usual. We have a vector field F here. And so in part A, we're asked here, use Green's theorem to write a double integral which computes the circulation F around C here. And so by Green's theorem, we know we can rewrite this as a double integral over R, something over this region here. What is the thing that goes in there? It's the partial derivative of, let's call this m and n here, is the partial derivative n with respect to x, which is x squared, minus the partial derivative of m with respect to y, which is negative y squared. And so this is going to be the double integral of x squared plus y squared dA. Okay, so now we have to evaluate this integral. Now we have to evaluate this double integral. How do we do this? Well, let's not try to do it from scratch here. Let's try to apply a change of variables. So it is suggested to us that we apply the substitution x is equal to u over v, y is equal to u times v. So what is the Jacobian of this transformation here? Partial derivative x with respect to u is 1 over v. Partial derivative x with respect to v is negative u over v squared. Partial derivative u respect to v is, partial derivative y respect to u is v. And then u here, so we end up with u over v minus times negative here is plus u over v squared times v, which is also u over v. So 2u over v is the Jacobian here. Okay, going from here, what will be the bounds on our new integral? So let's see here, x times y is going to be u over v times uv, and this is equal to u squared. The v's cancel. So u squared is between 3 and 8. And so everything here we can assume is positive here. So u will be between square root 3 and square root 8. Y over x. Y is u times v. X is u over v. The u's cancel, and we end up with v squared here. So v squared is also between 3 and 8. So v is also between square root 3 and square root 8. So as a result here, we can conclude that the bounds are integral. U will run from square root 3 to square root 8. V will run from square root 3 to square root 8. We need to make the substitution in the integrand. X squared becomes u squared over v squared. Y squared becomes u squared times v squared. We throw in a factor of the Jacobian. Everything in sight is positive, so we don't have to worry about absolute value. So here is our rewritten integral.